Okay, Assalamualaikum, and we meet again. So, uh, this is the lesson on the ripple output voltage. So, actually, the ripple output voltage, or sometimes we usually refer as a delta V out, is a very important parameters in designing the DC-DC converter. So, you may be confused what is actually ripple, because actually the output voltage here should be a DC voltage, right? Should be a DC voltage. A DC voltage here as constant DC. But actually, because it involves a switching, if you zoom in this area, so it's actually have some ripple. Okay, so this is actually the this is actually the ripple that we refer to. So actually the smallest the ripple, the better the DC-DC converter. But it is a very challenging design because to meet the design criteria, so some of the values need to be considered very detailed. Okay, so in this ripple output voltage, okay, the component that will affect this value is actually the capacitor. So we want to see what is the equation of this capacitor related to the ripple output voltage. So it is can be derived by looking at the waveform of the IC, okay, the capacitor current. So IC, so it's actually a ripple current that comes from the inductor itself. Okay. And to derive the equation of the ripple voltage and the capacitor, so actually we derive it because inside this capacitor, the capacitor charge can be actually written as it depends, okay, on the value of the capacitor and the voltage across this capacitor. And based on this circuit, the voltage across this capacitor is actually your V out. Okay, so any change in the charge is actually due to the change of the V out. So we rearrange this and use V out as our main function. So it will become like delta Q over C. And Q, actually, this charge of capacitor can be calculated by calculated the area of this graph. Okay, so this area of the graph is actually a triangular. So the charge of the capacitor can be calculated by 1/2 by the triangular equation, multiply with its height, the height right now. So this is I max, I min. So the height, the full height here is delta IL. So this one should be, this one should be delta IL over 2, right? So this one. So this one should be delta IL over 2, the height, and the base. The base is actually T over 2. So T over 2, or I can just write down 2 over F. So this one is actually delta IL over 8 frequency. Okay. And then we take this. So we have delta V out as equal to delta IL over 8 CF, right? Okay. Okay. So, and delta IL, so as I mentioned before, is equal to delta IL on, or you can use delta IL off. So in this case, I use delta IL off. Okay, only the magnitude, which is V out over L minus 1 minus DT. Okay, so my delta V out will be V out 1 minus D okay, 8, and then multiply with the C, multiply the frequency, because right now T is actually 1 over frequency. So I think this is it. Okay, so this is the equation for the ripple voltage, and it has a unit which is volt. Okay, which has a volt, and we have another parameter. So this one we call ripple voltage, and the other parameters is as a ripple factor. So what is ripple factor? What ripple factor is actually R is actually a ratio between delta V out over its V out. So this can be written down as a 1 minus T over L. Oh, sorry, this is, we have L here. Should have L. Okay, L C F. Okay, so this one L C F cos square. Okay, so this ripple factor, there is no unit because it is just a ratio. Okay, and sometimes we refer as a percentage. Okay, percentage. Okay, so that's all for the ripple voltage and the ripple factor. We meet again on the next topic, which is the boost converter.